So hello guys, today we are going to discuss insertion sort, how it works. So insertion sort is very similar to placing the cards at the correct position. Let me go on to the actual image. So it's something like we have the cards in hand and we remove the card and then we place the card, move the card to the correct position. So let me go through the uh, detail of the algorithm, how it's implemented. So in the insertion sort, we pick up a key and we compare it with all the elements on the left. So for example, uh, if like we have this array that is 51, 91, 31, 21, and 81, and indexes are this one. So here we will have let's suppose j here, and we'll have I here. So this j is basically our key. J is our key, and we'll keep on moving our key to the next element and compare. So first of all, in the first loop we'll compare that if, or we can say while, um, let me say that this array is named as v. So if v of j is smaller than v of I, and here uh, while I is greater than 0. So what we are doing here is we have to swap vj comma vi. Okay, so what we are doing here is we have j here, we have I here. We are just comparing if j is smaller than I, that is if 91 is smaller than 51. So this is not the case, so we will not enter in this while loop. Then we'll increment our I and j both. Now in this case we find that vj is smaller than vi, so in that case we'll swap both of them. So now how it will happen, how it will become, so after swapping, it will become 91, it will become 31, and we will decrement our I and j both. Now, our key, so in the first case, our key was, let me write it down, key was, okay, so here our key is 31, here our key was 91. So when our key was 91, we didn't perform any swap or anything, but in our case of 31, we performed one swap of 91 and 31. Now still our key is 31, so we'll compare if vj is smaller than vi, and yes it is, so we'll swap again. So now we'll have our 3 and 51 here. So if we see, 31 is at its relatively at its correct place as compared to all the elements on its left side. So let us move to the next key. So now our key will be, so earlier we reached 31, now we will start from 21. So our key will be 21. So now in this case we'll compare that if this key, that is Vj, is smaller than Vi. Yes it is. So we'll just swap. So what we'll have is, after swapping, we'll have 21 here and we'll have 91 here. We'll decrement I and j both. Again, we'll compare that our key 21 is smaller than the left element of it, that is vi. Yes, it is. So we will again swap. So in this case, it will become 51 and it will become 21. We'll again decrement, and again we'll compare that whether vj is smaller than vi. Yes, it is. So in this case, we'll again swap. It will become this. So 21 is at the correct place as compared to all the elements on its left. So now we have our last element, which we'll take as key. So our key in this case will be 81, and we will move over I and j to here. So now again we'll compare if vj is smaller than vi. Yes it is, and we'll swap. So after swapping, we'll have 81 and 91, and we'll decrement I and j. So I and j will be here. Now we'll compare that if 81 is smaller than 51. So no, this is not the case, and we will go to the next element, which is not there. So our array is sorted. So now if we see how this algorithm worked, we have taken one key, we have compared with all the left elements. If the immediate left element is greater than it, then we'll swap. So next time our key is 31, we have compared it with 91. Yes, it is smaller, so we'll swap. Then the key comes here. Next time we compare 31 with 51. Yes, it's smaller, and we swap it. So let me go to the actual code. So like we have taken 5, 2, 4, 6, 1, and 3. So in this case, we will be starting from element 1 because we will be starting from key as 91, and we have taken I is equal to j minus 1. So I is equal to j minus 1 here, and k is a temporary variable, so that when we move j to the back position, we do not require like j to be uh, uh, like remanipulated. So now in this case, what we are doing is while I is greater than or equal to 0 and Vi is greater than Vk. So it means what? Vi, that is the left element, is greater than this element. So in that case, swap is required. We have just swapped the elements, and we have decremented both I and j, that is I and k. And this is all the algorithm all about is. So when we reach the last element, we'll just compare the left element, and if the left element is greater than the current key, then we'll just swap it. So if I run this one, this works correct. Let me just change it to something. Let me just add some 51, 22, 43, 63, 11, and 32, and then let me run it. So it works fine again. So all the elements are sorted. So this is how this insertion sort works. And the complexity of insertion sort is O n square, because we have two for loops, one while and one for loop. So every element we have, every key we have to compare with all the elements on its left. So this works. O n square is in the case of a reverse sorted array. So that's all for the insertion sort. Thanks a lot. Have a good day.